Hey, this is Ken Rosever, and we're going to discuss summation of index data. And unfortunately, what happened was I just recorded this whole lesson, and my computer shut off. So here we go again. Maybe this one will be a little bit better. So when you look this up in Alex and you're doing this, the example they gave was a list of data. And in this case, there's 12 items of data, negative 14, 35, negative 62, blah, 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 blah. But what makes them indexed is that each one is paired with a particular number. When you look in an index in a book, the index tells you where a particular item of content can be found. And in the same way here, just as each piece of content has its own page, um, here, each item of data has its own number. So let me try to get this on pen. There, please work. Yes. So we see negative 14 is going to be given the number 1. So we're going to call this item x sub 1. This will be 35 is x sub 2. It's the second item in our list. All of these guys are x's. They're all members of our sample. This is the first member, the second member, negative 62 is the third member, so it would be x sub 3, and etc. all the way to negative 72 here, which would be x sub 12. There are 12 members in our list. Now, what a summation notation does is it tells us we're going to add up something. And what we're going to add up is the thing that follows. And you see here, this summation notation, I wrote it off to the side, is the summation of the x's as the index goes from 1 to 12. So basically what that means is we're going to add up all the xi's, but the I is going to go between 1 and 12. So what this means is x sub 1 plus x sub 2 plus x sub 3 plus x sub 4 plus da 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 x sub 11 plus x sub 12. So this right here is just a shorthand way of writing all this on the right side. It basically means we're going to go negative 14 plus 35 plus negative 62 plus negative 39. Because when we look at this, x sub 1 is 14. X sub 2 is 35. So we substitute in those values and then we add them all together and we will get our result, which I already know because I did this a couple minutes ago before the computer died. I believe it was 85. So let me put that in. And that's a very simple summation. Okay, the index on these things doesn't always have to start at 1. The index could start at 3, and it doesn't have to end at the last number. It could just be 3 to 8. Okay, x sub i's. And that would mean we would be adding x sub 3 plus x sub 4 plus x sub 5 plus x sub 6 plus x sub 7 plus x subscript 8. Okay, and you would basically sub in those values, and those would be negative 62 plus negative 39 plus da 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 all the way up to what's x8? That's x4. 5, 6, 7, 8 is 54. So So you could have like that. The index tells us, the index, which is I equals 3 up through 8, tells us where we're going to start and where we're going to end. In the original example, it was 1 to 12. In the second example I just made up, it's 3 to 8, but it could be anything. All right. The summation that they gave as an example and the one that they're going to give you in your quiz is not going to be so simple as just add up all the numbers. They're going to give you something a little more involved. So let me scroll down and I will show you something that's more like what they'll do. How do I do this? Um, Great, I don't know how to scroll down. Well, maybe I can grab this and move it. Yeah, I will move it off to the side here. I wonder if I can shrink it. All right, well, that'll be good. This 12 needs to be up there. Okay, oh, and so does that little 1. Ah, all right, let me do this now. So the one in the book, I apologize, I probably should have paused while I was doing that. Okay, the one in the book is a sigma notation like this. It says I equals 1 to 12. So we know we're going to use all the data items, but it doesn't say just x sub I. So we're not just adding each member of the sample. What it says is -6 times x sub I. So what we're really adding here is -6 x sub 1 plus -6 x sub 2 plus -6 x sub, whoa, x sub 3 plus dot 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 -6 times x sub 11 plus -6 times x sub 12. So you see, in every case, before we do the addition, we multiply by -6. So let's sub in the numbers now. -6. X sub 1 was -14. So we have a little -14 in there, plus -6 times 35, plus -6 times um, -62. That was x sub 3, plus, and if we went to negative x sub 4, it would be -6 times -39. And basically, you're doing this for all 12 numbers. Plus, dot, 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 -6, what's x sub 11? 45. And then 72. Now we could do all this out. We could go -6 times -14 is 84. -6 times 35 is 210. -6 times -62 is positive 372. And we could add up all these results. But when we have a -6 in each place, let me use my highlighter. Notice there's a -6 right here, right there, right there, right there. We have all these -6's. Each number in our list is multiplied by -6. So what we can do is we can factor out the -6. Let's pull out the -6 and what's left. If we pull the -6 out of every term, then we have this list left. Um, Oops, I forgot a negative up there. All right, so I pull that out, and then this list that we're left with here, well, that's just the sum of all the terms, or all the samples. So we have -6, really, times summation I 1 to 12 of the x sub i's, which we already calculated earlier was 85. So really our answer is going to be -6 times 85, which is -510. And that's how you do those. I hope this was helpful. Hopefully it won't freeze this time. Bye-bye.